Think about it. Everything around us is designed to pull our attention. The click, the like, the next video, and every time something inside of our brain lights up. For years, we've been told it's dopamine, the pleasure molecule. But what if it's not quite right? What if dopamine is not about pleasure at all, but about something much more fundamental, like prediction, decision, and learning? Lately, dopamine has been showing up everywhere, in my feed, in conversations, in books. So I decided to do a research to understand what dopamine really does to our brain. I looked into neuroscience papers, brain imaging studies, and latest theories. And what I found completely changed the way I think about dopamine, not as a shortcut to pleasure, but as something much deeper. The most common misconception is that dopamine is the pleasure molecule. It was prevailing theory for years, but modern neuroscience uncovers a more complex story. Dopamine is not primarily about the feeling of pleasure, the liking. In fact, it is more about the motivation, the anticipation, the craving for the reward. It is the wanting chemical. Try this. We used to think that when we eat something forbidden, let's say a piece of chocolate cake, our dopamine spikes. But in fact, the spike occurs not when we eat the cake, but when we look at it, when we think about it, when we order from our favorite bakery. One of the most surprising insights comes from the study by Berridge and Robinson. They found that when rats had almost no dopamine left in their bodies, they still showed pleasure from tasting something sweet. They just didn't seek it out anymore. Which means that dopamine is not the pleasure chemical, it is the wanting chemical. It is the drive that pushes us to pursue something we care about, not just to enjoy it. Dopamine is what makes us to get out of bed in the morning to get some breakfast, to pursue a career we love, but also dopamine is what makes us to pick up our phone for the 100th time. Dopamine's role extends even deeper. It is a fundamental learning signal. Imagine the brain makes a prediction about how rewarding something will be. And if reality is better than expected, dopamine neurons fire a burst, as if telling your brain, hey, that was surprisingly good, keep going, this is great. If reality is worse than expected, dopamine activity drops, as if telling your brain like, hey, that's not good, don't do it again. And if reality is exactly as expected, there is no significant change because the brain has already learned. This idea that dopamine is a learning agent comes from Wolfram Schultz. He recorded dopamine activity in monkeys and discovered that dopamine neurons didn't fire when reward arrived as expected, only when it was unexpected. And it stopped firing when reward was withdrawn. This shows dopamine signaling a reward prediction error, the gap between expectation and reality. This constant feedback loop helps our brain to learn and adapt. This is how habits are formed. This is how we learn from our experiences. This is how our brain is constantly fine-tuning the ways to pursue something we believe to be beneficial. Hey, quick pause. If you're enjoying the video, please like and subscribe. This channel is all about exploring ideas that matter, and I would love to have you along for the ride. Beyond motivation and learning, dopamine also plays a crucial role in movement. It helps to regulate precise and coordinated muscle control through a brain region called basal ganglia. According to the National Center of Biotechnology Information, in Parkinson's disease, neurons in substantia nigra, the ones that produce dopamine and send it to basal ganglia, they begin to die off. And as dopamine levels drop, it leads to disruption of the system that controls movement, leading to tremors, stiffness, and slowed motion. This shows just how fundamental dopamine is, not just for mental states, but for the very ability to navigate the physical world. So, if dopamine is so crucial, what happens when its balance is thrown off? We just mentioned Parkinson's disease, but dopamine dysregulation contributes to other conditions too. In addiction, dopamine system can be hijacked. Constant exposure to highly rewarding stimuli like drugs, gambling, even excessive screen time can shift the behavior from being intentional goal pursuit to a compulsive habitual cycle. With these intense experiences, the brain doesn't just remember the reward, it links it to cues in the environment. It remembers sights, sounds, even time of day. And soon, just seeing those cues can trigger the craving. Over time, the behavior shifts. It's not about chasing the reward anymore. It's about escaping the discomfort of not having it. The brain doesn't chase pleasure, it's trying to feel okay again. This is how a helpful learning system that's supposed to work for us can become a loop that is hard to break. Dopamine imbalances are also seen in conditions like ADHD and schizophrenia. In ADHD, research shows that low level of dopamine can make it harder for the brain to stay focused or feel motivated to start tasks. While in schizophrenia, high levels of dopamine in some brain regions can contribute to hallucinations and delusions, and low levels in others can cause lack of motivation and low energy. It's a complex system, and researchers are still trying to understand what's going on there. You must have seen the terms like dopamine detox or dopamine fasting, and this idea suggests that restricting from pleasurable activities like junk food, social media can reset your dopamine levels, boost your motivation, and it sounds very appealing, like a quick fix to modern overstimulation. But scientific reality is that dopamine is not a toxin that can be flushed out from our body. It's a neurotransmitter, a chemical messenger that brain cells use to communicate with each other. They transmit signals across synapses, the small gaps between neurons. When a neuron fires, it releases dopamine into the synapse. That dopamine binds to dopamine receptors on the next neuron, triggering a new electrical signal. This process is how our brain transmits thoughts, emotions, movement commands, and learning signals. The psychiatrist who popularized the term, Dr. Cameron Sepa, said it was intended as a behavioral tool to gain control over compulsive habits, not as a literal chemical detox. It's more a mindfulness-based stress reduction to regulate impulsive behaviors. And here I really want you to understand the difference between what they call dopamine detox and self-regulation in terms of dopamine. And my takeaway is, in dopamine detox, apart from the term being wrong, it suggests that by restricting certain activities, you can reset your dopamine balance and you will be motivated, you will be fine. But in reality, it's less about resetting something. It's more about keeping your brain healthy and your dopamine levels in balance, in a way that your brain will be more sensitive to less stimulating activities like walking on nature or playing with your dog will give you that motivation instead of pushing you to look for stronger stimuli. Supporting your dopamine system is not about extreme deprivation, it's about nurturing balance. Science supports several everyday habits that are both practical and proven to help. First of all, nourish your brain. Foods rich in tyrosine, the building blocks of dopamine, like lean meats, dairy, nuts, seeds, and leafy greens. Magnesium is also important, and it is of course recommended to limit junk food and excessive sugar because it can lead to unhealthy reward cycles. Movement. Exercise is one of the most effective natural ways to boost dopamine. Research shows that regular physical activity increases dopamine release in areas related to motivation and mood. Prioritize sleep. Sleep isn't optional, it's essential. Even a single night without enough rest can reduce dopamine D2 receptor, making you feel less alert and less motivated the next day. We all been there? Manage stress. Chronic stress wears on dopamine pathways, but practices like mindfulness, meditation, or time in nature can rebuild resilience. For example, one PET study found that meditation increased dopamine release in striatum, helping reduce reactivity. Genuine connection. Meaningful social interaction isn't just emotionally rewarding, it boosts dopamine too. Studies in both humans and animals show social engagement triggers dopamine pathways linked to reward and learning. Yeah, dopamine is far more than just a feel-good chemical. It shapes our motivation, helps us learn and move. And as soon as we understand how it really affects our brains and bodies, we start seeing all these ways it shapes our choices, so we can start building habits that support our well-being. This journey into the dopamine world has only deepened my appreciation of how incredibly complex our brains are. It's a reminder that something that might feel like A distraction or a struggle is actually our brain that is trying to learn and adapt and protect us. And this understanding might not fix everything, but it's a good start. If you liked the video, please like and subscribe. This channel is all about exploring ideas that shape us, and we're just getting started.